We already did this problem in class. This is practice 2. So pause the video, resolve the problem, and check your answer. When we solve for trusses, we always start with external forces. There are two forces given at joint B, which is F1, at joint D, which is F2. At joint A, we have a roller. Since the surface is horizontal, we know that the force on joint A will either go up or down, perpendicular to the surface. I'm going to draw it going up. And again, this is arbitrary, and if you solve it incorrectly, what happens is the sign becomes negative. At joint C, we have a pin. Joint C has a pin, so a pin has two forces, one going in the vertical direction, Y direction, and one going in the horizontal direction, X direction. I'm going to make my horizontal going to the right because it has to oppose F1, which is going to the left in joint B. Remember, this is statics. That means all the forces need to cancel out and equal to 0. If not, the bridge or the truss will rotate, twist, and break. Since F2 at joint D has 300 pounds, I'm just going to draw my force in the C going in the upward direction. And again, this is arbitrary. So if the forces are drawn incorrectly, once you calculate it, the signs will come out in the opposite direction. That means you need to redraw your forces. So after I draw my free body diagram of only the external forces, I must write a sum of moment equation. To do that, I need to pick a pivot point. Again, the pivot point should be the point which has the most unknown. In this situation, it's pivot point C. So remember, my sum of all the moments, I can have moment of A, moment of B, moment of C, moment of D. This must equal to 0. I already know there is no moment at C because remember, moment is equal to force times distance. However, the force must be perpendicular to distance, and at moment C, there is no distance because we're measuring everything from the pivot point. So we know that if I have moment A, this could be A, dA, B is going to be F1, dB, and then at D it's going to be F2, D equals to 0. So if I look at my force in A, my force in A is going up perpendicular to A, to my pivot point. This is my distance. It has to be perpendicular. So this is going to be labeled A. My distance is going to be 4 feet plus 1 foot. It's the total entire distance. We know what F1 is because F1 is given as 50 pounds. Perpendicular to B. So F1 goes this way to the left at joint B. My C is down here. Perpendicular is my vertical distance. So this is 2 feet. Remember, since these are vectors, the vectors can shift as long as they are parallel. F2 is given as 300 pounds. So the distance between the F2 vector, which goes down to C, has to be perpendicular again. So this is my D, so it's going to be 1 foot. this has to equal to 0. At this point, I'm going to account for direction because it's going to be a lot easier to keep track of your directions on your truss. So we stated by convention, if I rotate counterclockwise against the clock, this is positive. If I rotate clockwise with the clock, this is negative. So first thing I'm going to do is I'm going to draw my pivot point, which is C. My force for pivot point A goes up. So if I push my beam up, this is going to rotate in the clockwise direction. So that means A is going to have a negative moment. So I'm going to repeat the procedure for my B. So C is here. My joint B is in this direction. If you look at F1, it is being pushed to the left. So if I push this beam, it's going to rotate counterclockwise. So that one's going to remain positive. And then F2, if I look at F2, so I draw my C, F2 is here, located at D. If you notice, force is going down. So if I push it down, this is going to rotate counterclockwise, and this one is also going to be positive. So moment A was negative, and B and C, or B and D were both positive. Now I'm going to solve for my A. So A, negative A, 4 plus 1 is 5. So you're going to have 5. And I'm going to remove the units to make it a little bit easier. Plus 50 times 2 is 100. Plus 300 times 1 is 300. So if I add this, this is negative A times 5 plus 400. This has to equal to 0. Remember, all the moments have to equal to 0. I'm going to add a 5 to both sides. So if I add a 5 to both sides, this becomes 400 equals to 5A, divide by 5, divide by 5. A should become 80 pounds. If you notice, it is positive. Since it's positive, the way I drew my vector is correct. So A is going to go up. Now I'm going to write a sum of Fy and Fx equation. It doesn't matter which one you do first. I'm just going to do sum of Fy. It has to equal to 0. In the y direction, we have 3 vectors. I have A, I have Cy, and I have F2. They have to go in the vertical direction. Going up, I'm going to make positive. So sum of Fy is going to equal to A plus Cy minus F2 equals to 0. So if I solve for Cy, this becomes F2 minus A, and F2 was given as 300 pounds, minus A, which we solved as 80 pounds. So if I do my math, this will become 220 pounds. And since it's positive, I knew I drew my C vector correctly. It's going to go up. Next, I'm going to write a sum of Fx equation. That also has to equal to 0. In general, I usually make going to the right positive. So Cx is going in the positive direction, minus it is opposed by F1. Remember, these are only vectors that are going in the horizontal or the x direction. So Cx is equal to F1, and we know F1 is equal to 50 pounds because this was given to us. Since it came out positive, I know my direction is going to the right. Now we finished all our external forces. Now that we solved for all the external forces, we are going to start with the internal forces. We are going to use the method of joints. Again, you want to pick the joint that has the least amount of forces and least amount of angles. You do not want to start at joint D because you do not know any of the horizontal values. So we don't know any of the horizontal measurements, so we're not going to start there. I'm going to start at joint A. So the first thing I do is I draw a free body diagram. I know A is going to go up because I solved it in the previous slide. There are two beams. I have a beam that goes AB that goes either southwest or northeast. And then I also have another beam, AD, that could go west or east. Since I know A goes up, beam AB must go southwest. Remember, in trusses, all the sum of the forces must equal to 0. If A goes up, the only beam that could provide a y component is AB, because anything at an angle has a y and an x component. So AB is going to go down to the south, and since it's going to the west, that means AD, to counteract it, must go to the right. In statics, all the forces must cancel out to 0. If not, the truss, the bridge, will rotate, twist, and break. Since AB is at an angle, we must resolve it into x and y. So it's going south, and it is going to the west. This angle is provided in the problem. So I know this is ABX because it's going to be next to, so it's going to be AB cosine theta. ABY is opposite, so it's going to be AB sine theta. So I'm going to redraw this. We already know A goes up. It is going to be opposed by ABY. We know that AD is going to the right, and then ABX is going to the left or west. Sum of Fy and sum of Fx. So sum of Fy is going to be all the vectors in the y direction. A goes up, so I'm going to make that positive. It is opposed by ABY because it's going in the negative direction. This is equal to 0. So ABY is equal to A, and we know that ABY, after we resolve the components, is AB sine theta is equal to A, and we're going to divide both sides by sine theta. So AB is going to be A over sine theta. We know A is 80 pounds divided by sine 26.6 degrees. So you should get approximately 179 pounds. Since the answer came out positive, we know that the joint goes in the southwest direction. So after we solve for it, remember, we need to label the truss with the correct direction. So this one is going to go in the southwest direction. And we're going to repeat the procedure for sum of Fx. So sum of Fx is going to be AD going in the right minus ABX because it's going in the opposite direction. So AD is equal to ABX, and we know ABX is what? AB cosine theta from here. So AD is going to be AB, which we solved as 179 pounds down here, cosine 26.6 degrees. And if you do the math correctly, AD becomes 160 pounds going to the right. And again, since it came out positive, we drew the picture correctly, the direction. So I'm going to mark that on this original structure. So now we're finished with joint A. The next joint to go to is probably D. D is the next easiest one. So joint D has F2 going down, which was given. So that means to oppose F2, the force from DB must go up to counteract it. We solved for joint the beam AD, and at joint A we said it went to the right. So at D it must oppose that force, so it's at static. So it must go to the left. So that means that DC must oppose it and go to the right. All the vectors are parallel and perpendicular. I do not need to resolve vectors. So all I'm going to do is write my Fy equation. My Fy equation going up is dB minus F2, which is going in the opposite direction, equals 0. So dB is equal to F2, and F2 was 300 pounds, came out positive. So I drew my direction correctly, and it's going up. My sum of Fx is going to be DC going to the right, opposed by dA going to the left, equals to 0. So DC is going to equal to dA, and we solve dA as 160 pounds. Since it came out positive, the way we mark the direction, it is correct. It is going to the right. So now I know that this beam is 160 pounds. I know AD has a force of 160 pounds. And I know AB has a force of 220 pounds. And I know DB has a force of 300 pounds. So I only have one more beam to do, which is BC or CB. I probably do not want to do joint B, because joint B, if you notice, there are two beams that are at an angle. So I want to do my last joint for C. So I'm going to draw my free body diagram for joint C. I already know CY is going up because we solved it. I know my CX is going to the right because I already solved that. And then I also know that joint CD has to go to the left. Why? Because if you look at the picture from joint D, we know that DC is going to go right. For the beam to be at static, the force from joint C has to oppose it. So I know this one's going to go to the left. So we have one more beam, which is BC. So BC can either go northwest or southeast. Since we know CY goes up, because we solved it to go up when we did the external forces, the only force that can oppose it is from BC or CB. So I know the joint has to go southeast to oppose it. So after I draw my free body diagram, my CB beam is at an angle, so I need to resolve this into beam CB is at an angle. I need to resolve that into X and Y. So it's going to go south and it's going to go to the east. This angle was provided for you on the worksheet. Since this is next to CBX is going to be CB cosine theta. CBY is going to be CB sine theta because it is opposite. So now I'm going to redraw my forces. So I know CY goes up. This is opposed by CBY going down. I know CX is going to go to the right. I know CD is going to go to the left. And I also know CBX is also going to go to the right because it is the beam BC is going southeast. So I know I need to solve for one more beam, that is CB or BC. The easiest equation is going to be the y direction because there's only two vectors. In the x direction, there's three vectors. So that means the sum of Fy is equal to Cy going up minus Cby going down. This has to equal to 0. So Cby is equal to Cy. Cby, I'm going to substitute in, is Cb sine theta equal to Cy. I'm going to divide both by sine theta. So that becomes Cy, which we solved as 220 pounds, divided by sine of the angle, which is 63.4. This was given in your worksheet. And so that means CB or BC is equal to 246 pounds. Came out positive, so the direction we drew in is correct. Now I'm going to mark all my directions. So this one is going down here. So at joint B, it has to go up to oppose it. And beam AB, it has to go towards B to oppose. Since we solved all the beams and external forces, we are done. Now we have to figure out if the beams are in tension or compression. So let's start with joint A. If I look at my joint A here, the beam is going towards the joint or pushing at the joint. So this is in compression, it's pushing. So this beam here is in compression because it's doing the same thing at joint B. It's going towards, the force is being pushed towards B. We know that BC is also in compression because the arrow is pointing towards the joints. So that means it's pushing in. AD is going to be in tension, it's going away. The arrows are going away, so the forces are being pulled away. If I look at DC, again, the arrows are going away, so this is also in tension. And then in BD, the arrows are also going away from the joint, so this is also in tension. Tension forces go away from the joints. Compression forces go towards the joints.